Section 24 of Gray's Anatomy, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Laurie Ann Walden. Anatomy of the Human Body, Part 2, by Henry Gray. Section 24, Myology. The muscles are connected with the bones, cartilages, ligaments, and skin, either directly or through the intervention of fibrous structures called tendons or aponeuroses. Footnote: the muscles and fascia are described conjointly in order that the student may consider the arrangement of the latter in his dissection of the former. It is rare for the student of anatomy in this country to have the opportunity of dissecting the fascia separately, and it is for this reason, as well as from the close connection that exists between the muscles and their investing sheaths, that they are considered together. Some general observations are first made on the anatomy of the muscles and fascia, the special descriptions being given in connection with the different regions. End footnote. Where a muscle is attached to bone or cartilage, the fibers end in blunt extremities upon the periosteum or perichondrium, and do not come into direct relation with the osseous or cartilaginous tissue. Where muscles are connected with its skin, they lie as a flattened layer beneath it and are connected with its areolar tissue by larger or smaller bundles of fibers, as in the muscles of the face. The muscles vary extremely in their form. In the limbs they are of considerable length, especially the more superficial ones. They surround the bones and constitute an important protection to the various joints. In the trunk they are broad, flattened, and expanded, and assist in forming the walls of the trunk cavities. Hence the reason of the terms long, broad, short, etc., used in the description of a muscle. There is considerable variation in the arrangement of the fibers of certain muscles with reference to the tendons to which they are attached. In some muscles the fibers are parallel and run directly from their origin to their insertion. These are quadrilateral muscles, such as the thyrohyoideus. A modification of these is found in the fusiform muscles, in which the fibers are not quite parallel, but slightly curved, so that the muscle tapers at either end. In their actions, however, they resemble the quadrilateral muscles. Secondly, in other muscles the fibers are convergent. Arising by a broad origin, they converge to a narrow or pointed insertion. This arrangement of fibers is found in the triangular muscles, for example, the temporalis. In some muscles, which otherwise would belong to the quadrilateral or triangular type, the origin and insertion are not in the same plane, but the plane of the line of origin intersects that of the line of insertion. Such is the case in the pectineus. Thirdly, in some muscles, for example, the peronei, the fibers are oblique and converge, like the plumes of a quill pen, to one side of a tendon which runs the entire length of the muscle. Such muscles are termed unipinnate. A modification of this condition is found where oblique fibers converge to both sides of a central tendon. These are called bipinnate, and an example is afforded in the rectus femoris. Finally, there are muscles in which the fibers are arranged in curved bundles in one or more planes, as in the sphincters. The arrangement of the fibers is of considerable importance in respect to the relative strength and range of movement of the muscle. Those muscles where the fibers are long and few in number have great range, but diminished strength. Where, on the other hand, the fibers are short and more numerous, there is great power, but lessened range. The names applied to the various muscles have been derived: 1. From their situation, as the tibialis, radialis, ulnaris, peroneus. 2. From their direction, as the rectus abdominis, obliqui capitis, transversus abdominis. 3. From their uses, as flexors, extensors, abductors, etc. 4. From their shape, as the deltoideus, rhomboideus. 5. From the number of their divisions, as the biceps and triceps. 6. From their points of attachment, as the sternocleidomastoideus, sternohyoideus, sternothyroideus. In the description of a muscle, the term origin is meant to imply its more fixed or central attachment, and the term insertion the movable point on which the force of the muscle is applied, but the origin is absolutely fixed in only a small number of muscles, such as those of the face which are attached by one extremity to immovable bones, and by the other to the movable integument. In the greater number the muscle can be made to act from either extremity. In the dissection of the muscles, attention should be directed to the exact origin, insertion, and actions of each, and to its more important relations with surrounding parts. While accurate knowledge of the points of attachment of the muscles is of great importance in the determination of their actions, it is not to be regarded as conclusive. The action of the muscle deduced from its attachments, or even by pulling on it in the dead subject, is not necessarily its action in the living. By pulling, for example, on the brachioradialis in the cadaver, the hand may be slightly supinated when in the prone position, and slightly pronated when in the supine position. But there is no evidence that these actions are performed by the muscle during life. It is impossible for an individual to throw into action any one muscle. In other words, movements, not muscles, are represented in the central nervous system. To carry out a movement, a definite combination of muscles is called into play, and the individual has no power either to leave out a muscle from this combination, or to add one to it. One or more muscle of the combination is the chief moving force. When this muscle passes over more than one joint, other muscles, synergic muscles, come into play to inhibit the movements not required. A third set of muscles, fixation muscles, fix the limb, for example, in the case of the limb movements, and also prevent disturbances of the equilibrium of the body generally. As an example, the movement of the closing of the fist may be considered. 1. The prime movers are the flexores digitorum, flexor pollicis longus, and the small muscles of the thumb. 2. The synergic muscles are the extensores carpi, which prevent flexion of the wrist. While 3. The fixation muscles are the biceps and triceps brachii, which steady the elbow and shoulder. A further point which must be borne in mind in considering the actions of muscles is that in certain positions a movement can be effected by gravity, and in such a case the muscles acting are the antagonists of those which might be supposed to be in action. Thus, in flexing the trunk when no resistance is interposed, the sacrospinales contract to regulate the action of gravity, and the recti abdominis are relaxed. Footnote: consult in this connection the Cronian Lectures, 1903, on Muscular Movements and Their Representation in the Central Nervous System, by Charles E. Beaver, M.D. End footnote. By a consideration of the action of the muscles, the surgeon is able to explain the causes of displacement in various forms of fracture, and the causes which produce distortion in various deformities, and, consequently, to adopt appropriate treatment in each case. The relations, also, of some of the muscles, especially those in immediate apposition with the larger blood vessels, and the surface markings they produce, should be remembered, as they form useful guides in the application of ligatures to those vessels. End of section 24.